Alright guys, I'm going to go over Firestarter 20, 21, 22, 23, and 24 all in one video. Remember, everything's going to come back to this chart that's on the top right. That's like your hint page. So if it doesn't have an equal sign in the original problem, then it is probably a simplified problem. If it has a letter equal to a number of some type of sort, it's going to be a solved problem, and that's going to depend on what you do. Now we start off with this. I'm going to start off by first, we're going to evaluate. So the square root of 121 is just 11. Square root of 100 is just 10. The square root of 36 is just 6. Square root of 361 is 19. Notice I do not have, like earlier we had 121 and we had equal to 11 squared, right? So when I square root both sides, the little 2 and the check mark cancel. That's why the square root of 121 is actually just 11. And you can keep on going, 9, 7, 17, 3, 5, 18, wrong, 8, 13, 4, 1, 196 is 14 times 14, so 14 squared, 16 is 256, 15 is 2, I don't know what I'm thinking today, 15, 2, 12, and 20. Now, one thing you might want to think about adding is, technically, when I square root both sides, plus or minus shows up. I'm not very picky if you don't have the plus or minus when it comes down to numbers. Remember, like 9 squared is 81, but also at the same time, negative 9 squared can be 81, so the square root is the inverse of that, so both those have to be accounted for. All right, that makes sense. So, make this a little bigger now. So now we're going to go over and use we're going to break down the radicals. So 2 and 3 are simplified problems because there is no equal sign. So simplifying, the first thing I have to look at every single time is I have to make sure and find out if there's going to be a perfect square inside the radical. So right away I see 7/3. Now when I look for a perfect square, that's using all of these numbers right here. Right, it's all these numbers right here. That's trying to find a number on that list, those blue numbers, that break down inside the radical. There's no fractions on the list, so one of the first things we do here is we take the radical to the top and the radical to the bottom. So radical 7 is not on the list. It cannot be broken down by anything in the list, so it's good. 3, not on the list. So according to rule number 1, nothing's wrong in the beginning of this problem. But there is also a rule that says you cannot have a radical on the bottom. So radical 3 is not allowed to be in the bottom. Whenever we see a radical on the bottom, that's when we're going to use conjugates. So the first thing I'm going to do, I'm going to make my conjugate box. Remember, that's how you get your free point. So if you're lost and you see a radical on the bottom, get your free point to make sure you tell me you're trying to understand what I'm telling you. So now remember, radical 3 kind of looks like an easy conjugate, so I put radical 3 on the bottom. If that was radical 8, I put radical 8. I just make it match. Now, because it says to make it match. Now, I copy whatever's on the bottom on the top because remember, same over same. That means both the top and the bottom have to be the exact same. So 7 and 3, they're both in jail, so I get to multiply them together. I have square root of radical 21. 3 and 3 are both in jail, square root of 9. So it's equal to the square root of 21 all over 3. And I can't divide the 21 by the 3 because 21 is in jail and 3 is not. Now, if you don't want to go through this, that shortcut tells me you could have skipped this last step right here. But I didn't actually show the work. And I will probably for the first couple of these. So number 3 is the simplified problem. Rule number 1, nobody's breaking rule number 1. Radical 5 is on the bottom, not breaking any rules. So that means I'm going to make my conjugate box show up. I know it's a simplified problem because there's no equal sign. Now this looks like a hard conjugate. So I'm going to use the opposite of that, or the conjugate soulmate. Remember, conjugates are the two sets, and the only two numbers that multiply together that make the radical disappear. So there's only one conjugate here, 6 minus radical 5. And then I literally just copy and put that onto the top, 6 minus radical 5. So I have 5 all over 6 plus radical 5. Because remember, when I multiply, I put them on one fraction bar. So the top I'm going to distribute. 5 goes to both. 5 times 6 is 30. Remember 5. And now I go 5 times negative radical 5. 1 5 is out of jail. 1 5 is in jail, so they cannot be smashed together. That's why it has to be 5 radical 5. Now the bottom I'm going to FOIL. So 6 goes to 6. That's 36. 6 goes to minus radical 5. That's minus 6 radical 5. Radical 5 goes to 6. That's plus 6 radical 5. And then radical 5 goes to negative radical 5 because of the minus because radical 25. Although this is really ugly looking, we have not made a mistake. Everything happened the way it was supposed to happen. If you guys don't see this, look, these are opposites. They cancel. And the square root of 25 is 5, so this whole thing turns into minus 5. So these were conjugates because when I FOILed them correctly, the radical disappeared. So the best answer for this really should be 30 minus 5 radical 5 all over 36 minus 5 is 31. Now, I have no problem with you having the answer like this. Some people will rewrite the answer, and it's called splitting the fraction. They'll take the 31 to both pieces. So either one of those are good answers. All right? So number 4 is a solve problem because that's PEMDAS backwards. So first thing I do, if I want to get a free point, if I'm lost, I put this on my paper. This tells me you're trying to listen to what I'm telling you to do in class. I look at number 4, there's no subtraction, there's no addition, there's no division, there's no multiplication, there's an exponent. How do you get rid of exponents? Square root. So I square root both sides. The reason this plus or minus is there is whenever I square root both sides, plus or minus shows up in the next step. The little 2 and the check mark cancel each other out in the radical. So I have the x equals the square root of 81. Now remember, 81 is perfect, so he gets to leave jail as long as he turns into 9. So the best answer is x is equal to plus or minus 9. Now you could write it as x equals 9 or x equals negative 9 if you want to write it out. I don't really care which way you write it. But it's very unlikely for me to see this if you didn't have the plus or minus there. All right. 5, once again, one variable, so the first thing I'm going to do is I'm going to put PEMDAS backwards. So I know it's a solve problem. Now I'm going to start at the bottom. Do you see any subtraction? I don't. I see addition. How do I get rid of addition? I use subtraction. That's why the first thing I do is I multiply 10 by both sides. I end up with 3x squared equals 144. Now the most common mistake I see here is somebody square roots because they see 144 and they get distracted because that 144 is so pretty and perfect looking. So do not get distracted by the pretty perfect 144. Remember, we're following PEMDAS backwards. It has nothing to do with the 144. Because if I square root both sides now, the right side's nice, but the left side's really messy. So I look at the PEMDAS backwards rule. There is no division, there's multiplication. How do I get rid of multiplication? I divide both sides by 3. So now I have x squared equals 144 divided by 3 is 48. Now that the multiplication is gone, I can finally get rid of the exponent, so I square root both sides. I end up with x equals, remember, plus or minus shows up as soon as you square the square root of 48. And now I got to use rule number 1. I got to use this list of numbers here and to see if there's something in there that goes into 48. Well, I know 48 is 16 times 3. So 16 gets to leave jail as long as he turns into 4. So your best answer should be plus or minus 4 radical 3. And that's it. Now, number 6, the most common mistake I see on number 6 is people try to get rid of the parentheses first. Now, I'm not saying that in Algebra 1 that would have worked because the little 2 wasn't there to mess you up. So my recommendation for anybody is whenever you're using this, don't worry about any getting rid of parentheses. Don't worry, just follow PEMDAS backwards no matter what. So for example, I see subtraction right here. but that subtraction is actually in the parentheses, so I can't get rid of it. You cannot get rid of the multiplication by distributive property, because remember, that's not how we get rid of multiplication. We get rid of multiplication by division. So I am not allowed to distribute the 5. I can't distribute the little 2, because that's not how we get rid of exponents. We get rid of exponents by the square root. So there's no way that's the right way to do it either. So I'm just going to start at the bottom. There is no subtraction. Even though it's subtraction, it's really actually in the parentheses. There's no addition, there's no division, there's multiplication. So how do I get multiplication? I divide both sides by 5. So even though it looks like that's the easiest way to get rid of parentheses by distributive property, it's actually not. 40 divided by 5 is 8. Now that subtraction is still in the parentheses, so I'm still not going to get rid of it. So I got to get rid of the exponent first. Well, how do I get rid of an exponent? I square root both sides. Remember, whenever I square root both sides, plus or minus shows up. So I have plus or minus square root of 8. Now, the parentheses are finally gone, so I'm finally now allowed to get rid of the subtraction. Remember, you get rid of subtraction by addition. So remember, the plus or minus already showed up, so your best answer is this. X equals 3 plus or minus square root of 8. Now, it would be really messed up for me to teach you all this stuff about breaking down radicals and forget it at the end. So you do have to make sure 8 can't be broken down, and it can, because 4 is perfect and it goes into 2. So this is going back to rule number 1 about radicals. So the best answer for this is actually x equals 3 plus or minus this 4 turns into a 2. This 2 is a 2 that stays in jail forever. So that's your best answer. Like I said, that can be written twice as well. All right, I'm not going to spend any time going over the chart, so if you want to go over the chart, I did on a couple other Firestarters. 121 is 11 squared, 100 is 10 squared, 36 is 6 squared, 361, 19 squared, etc., etc., etc. So, number 2, remember, I'm simplifying radicals, so I'm using these rules right here. And as soon as I see that the first thing I'm going to do is I'm going to take the radical to the top, radical to the bottom, and it's because there's no fractions on this list here and here. Now, radical 5 and radical 2, they're not breaking any of those rules. So the first thing I'm going to do is I'm going to look for a radical on the bottom, which tells me to use conjugates. As soon as I see a radical on the bottom, I make my conjugate box, because that's my free point. And it's an easy conjugate, because it looks like this right here. So my conjugate soulmate is going to be radical 2. Remember, it's one time I won't yell at you for copying. Copy whatever you put on the top from the bottom, and that has our conjugate box. Now we're going to multiply across the top, so 5 and 2 go together, and multiply across the bottom. So I have radical 10, because both those guys are in jail, so I can multiply them together over radical 4. Remember, the square root of 4 is 2, so my best answer for this is radical 10 all over 2. And 10 cannot be broken down, so we're done. Now I'm going to do the same thing with the next one, number 2, or number 3, I mean. So I look at the bottom. I see one radical, radical 2. Radical 2 is not breaking rule number 1 because it cannot be broken down. So I know right away I need a conjugate box. So the first thing I do is I make this box. Remember, it is a hard conjugate because the bottom kind of looks like this. So that means my conjugate soulmate is going to be the same exact thing, and I just put a minus in the middle. That's the only difference between the two conjugates. And when they're hard, you just change the sign in the middle. And remember, the top and bottom have to match. So I have that on the top as well. That's why I have same over same there to remind you the top and bottom must be the same. Now remember, I'm going to have, these are going to be multiplied together. So that's what happens in fractions when they get multiplied together. They just all go over one fraction bar. Now the top should look like something we've done before, distributive property. So I get 21 minus 3 radical 2. And the bottom is FOIL. So I'm going to do 7 goes to 7. 7 goes to minus radical 2, so it's minus 7 radical 2. Remember, 7 not in jail, 2 is in jail, that's why they can't be smashed together. Now, radical 2 is going to go to the 7. Remember, 2 is in jail, 7 is not, so it's plus 7 radical 2. And then finally, radical 2 and radical 2, they're both in jail, so it's minus radical 4. We did not mess up, even though this is really messy right now. Look at this. those cancel just like we had hoped. That turns into minus 2. So the whole thing on the bottom becomes over 49 minus 2, which is 47. And the top stays the same, minus 3 radical 2. I would have left it like that, but like I said, some places are going to split it, where you're going to have 21 over 47 minus 3 radical 2 over 47. Either way is a good answer with me. I think it's easier just to keep them together. That's it for 3. 4, if you're struggling, remember, PEMDAS backwards. If you're struggling, use PEMDAS in reverse. 1, it's a free point on a solve problem. 2, it's going to help you step by step. So I literally attack every single problem, whether it looks like 4, 5, or 6, I attack every single problem exactly the same. I look for subtraction. 4, there is none. And there's no addition. There's no division. There's no multiplication. There's an exponent. How do I get rid of exponents? I square root both sides. The reason that little plus or minus is there is to remind you whenever you square root both sides, the plus or minus shows up. So the plus or minus square root of 49, well, 49 is perfect. See, it's right here. So I get x equals plus or minus 7. Done. That's it. 5, exactly the same thing. The first thing to do is PEMDAS backwards. All right, there is no subtraction, there's addition. That's why I'm minus 5 from both sides first. I have 3x squared equals 36. Once again, I don't care that 36 is perfect. I'm looking for division next. I'm looking for multiplication, which I see, which is why I divide by 3 to start. If you try to do square root, then it's going to get really messy. So I end up with x squared equals 12. Now I'm working on exponents, and that's why I square root both sides. So I end up with x equals plus or minus, because I squared it both sides, the square root of 12. Now remember, plus or minus, or remember 12 is not on my list, but 4 goes into it 3 times. So I do have to break it down. So my best answer for this one is actually x equals plus or minus. This 4 turns into 2 outside the radical. 3 stays in jail forever. Six, exact same concept. Once again, do not get distracted by that and try to distribute it. That is not okay. Also not allowed to do that. 2 most common mistakes I see, and that's because you're trying to get rid of the parentheses either by multiplication or you're trying to get rid of the exponents by multiplication or distributive property. That is not what PEMDAS backwards says to do. PEMDAS backwards is a step-by-step process, so every problem is the same. For example, I see subtraction, but it's in the parentheses, so really it's parentheses. Now, I look for addition, I don't see any. Division, don't see any. Multiplication. I don't get rid of multiplication by multiplication, I get rid of multiplication by division. That's why the first thing I do is divide both sides by 3. I end up with x minus 2 squared equals 7. The subtraction is still in the parentheses, so I have to get rid of the exponent next. That's why I square root both sides first. Remember, when you square root both sides, plus or minus shows up, so I have plus or minus the square root of 7. And I'm finally allowed to get rid of my subtraction now. So I finally add 2 to both sides. So x equals 2 plus or minus radical 7. That's it. All right, Firestarter 22, exact same concept, so I'm going to go a lot quicker now. So right away, remember, number 1, there's a radical on the bottom. It is not bringing the earlier rules, so as soon as I see that radical on the bottom, I think conjugates. It's an easy conjugate, so I'm going to pick radical 3 to go on the bottom. That's his soulmate. Remember, the soulmate is the only guy that multiplies together and make the radical go away. There's only one. So I take the radical 3, I put it on the top and the bottom, and now I multiply across the top. 8 radical 3 all over. Remember, my shortcut I'm going to use now to save some time. I know the bottom's going to become 3, and I'm done. Number 2, I see a radical on the bottom. Once again, I know conjugates, so I make my conjugate box. It is a hard conjugate, so it looks like this. So I'm going to use that. I'm going to put 1 radical 3 on the bottom. 1 plus radical 3 goes on the top. Remember, those have to match. Now, and this is how I would do it. I already know these are going to be multiplied together, so I already know the top is going to be distributive property. So now the top is going to be 2 plus 2 radical 3. Now I'm going to use my shortcut here, which says find a, that's a, I square it, so 1 squared, minus b, minus 3, 1 squared is 1, 1 minus 3 is negative 2. So without doing any work, I get 2 plus 2 radical 3 all over negative 2. You could definitely FOIL this out and get the same answer, just as way faster. The last thing you should do is split the fraction. So when you split the fraction, you actually end up with negative 1 minus radical 3. That's your best answer. So 3, PEMDAS backwards, write it once again, PEMDAS backwards. If you're stuck on 3, that's the first thing you do because it's a solve problem. No subtraction, no addition, no division. No multiplication. There's an exponent, and that's why you square root both sides. I end up with a equals plus or minus because I squared root both sides in 50. And that brings us back to rule number 1. Remember, 25 goes into 50 2 times. So the best answer for this is a equals plus or minus. This 25 turns into 5. 2 stays in jail forever. Best answer. Number 4, exact same concept. If I am struggling, the first thing I do is I say PEMDAS backwards. I see subtraction, so that's why I add 6 to both sides. I get x squared all over 25 equals 4. There are multiple ways to do this problem. I'm going to do it this way, so it's always the same. There's no subtraction. We got rid of subtraction, no addition. There's division. That's why I multiply by 25 first. And with x squared equals 100. Division's gone. No multiplication. There's an exponent. That's why I square root both sides. So I end up with x equals, remember, plus or minus shows up. 100 is perfect, so the whole thing turns into plus or minus 10. Done. The reason I do it this way, even though sometimes it feels different or awkward, it's because it's the same step-by-step process. So I look at number 5. First thing I do is look for subtraction. I don't care about the exponents. I don't care about the multiplication. I don't care about the parentheses. I literally look for subtraction first. I find it. That's why I add 5 first. So I end up with 2 over x plus 2 squared equals 13. Subtraction's gone. There is addition, but it's really inside the parentheses, so I'm not able to get rid of that yet. No division. There's multiplication, and that's why I divide both sides by 2. Now remember, we cannot continue to discriminate against fractions forever. We are going to leave 13 halves over 13 halves. I'm not going to write 6.5. I'm just going to leave it as a fraction. That's totally okay. Multiplication is gone. The addition is still in the parentheses, so I'm not get rid of it, so I have to get rid of the exponents, and that's why I square root both sides. So I end up with x plus 2 equals plus or minus the square root of 13 over 2. Now my addition is finally out of the parentheses, and that's why minus 2 from both sides. Now it's important to note the plus or minus showed up ahead of time. That's why the minus 2 is in front of the plus or minus. Remember, we broke down radicals just like number 1, or number 1 on a couple of the other problems. Firestarters, I take the radical at the top over the bottom. 2 is not allowed to be on the bottom because I got a fraction. So this is just remembering what we did with simplifying radicals from earlier in the Firestarter. So the conjugate is radical 2 over radical 2. So to finish this out, I end up with x equals negative 2 plus or minus. I multiply across the top, I get radical 26. My shortcut tells me I just get 2 on the bottom. So that's the best answer. This answer, before you broke it down, the answer probably would have got you 3 out of 4 or 4 to 5 points. All right, 23, exactly the same concept. So I look at number 1. Remember, we have a fraction. There's a radical on the bottom, so I'm using conjugates. So I make my box. Get your free point. Make sure you understand how to make the box. It's a free point. Remember, it's an easy conjugate, so I use radical 5, and I copy that to the top. I multiply across the top, so 7 times 5. Remember, radical 5 is in jail, 7 is not, so it becomes radical 5. Now I'm going to use my shortcut here that says if the radicals are exactly the same, I just write it without the radical. Done. Shortcut makes your life a little bit easier, especially on number 2. So I make my conjugate because I see a radical on the bottom. It is a hard conjugate. It looks like this. So I make my soulmate look like this. So it's 2 plus radical 5. Now the top becomes 2 plus radical 5 because remember, same over same. So now 3 is going to go to the 2, 3 is going to go to the radical 5. 2 is not in jail, so 3 and 2 can multiply together. Radical 5 is in jail, so it becomes plus 3 radical 5. Now I'm going to use my conjugate. I'm going to use my conjugate shortcut here. So my conjugate shortcut says that I take 2, and it's a squared. So I take 2 and I squared, I get to 4, and this is my b. So I put minus 5. So the bottom becomes just 4 minus 5. That's it. So I don't have to FOIL it. It's way easier if I don't try to FOIL it. So I have 6 plus 3 radical 5 all over 4 minus 5, which is, remember that turns into negative 1. So I'm going to split my fraction because it's negative 1. I end up minus 6 minus 3 radical 5. That's the best answer. All right, number 3, remember PEMDAS backwards. If you're struggling, PEMDAS backwards is where you start. So if you tell me you're lost, I should at least see that on your paper. That's like the effort points. No subtraction, no addition, no division, no multiplication. There's an exponent. So I square root both sides. I get a equals plus or minus the square root of 150. Well, 25 goes into it. 6 times 25. So my best answer is a equals plus or minus this 25 turns into 5. This 6 stays in jail forever. Done. Next one, number 4, first thing I do, PEMDAS backwards in case I'm lost. I see subtraction. That's why the first thing I do is I add 8 to both sides. I'm left with x squared all over 36 equals 6. Now, subtraction's gone. There is no addition. There is division. That's why the next thing I do is I multiply by 36. So I multiply both sides by 36. I'm left with x squared equals 216. Division's gone. There is no multiplication. There's an exponent. That's why I square root both sides. X equals, remember, plus or minus shows up. Square root of 216. Now, 216 is not perfect, but I know 36 goes into it 6 times. So my best answer for this is x equals plus or minus 6. This 36 turns into 6. This 6 stays in jail forever. So that's your best answer. All right, 5, we have PEMDAS backwards again. We start with that. Remember, it's a solved problem. There's an equal sign. There's one variable. So I see subtraction. That's why the first thing I do is I add 10 to both sides. I have 3x plus 5 squared equals 18. Now, there's subtraction. The addition is actually inside the parentheses, so I can't get rid of the plus 5. Don't fall into the trap of trying to get rid of the 3 by multiplication or trying to get rid of the exponent by multiplication. Just follow the steps. No division. There's multiplication. That's why I divide by 3 on both sides. And this one's even easier than the last one we did because 18 over 3 is nice. But even if 18 over 3 was nice, I'm still going to divide at that point. Now I have to square root both sides because there is an exponent. And the addition is still inside the parentheses. So I end up with x plus 5 equals plus or minus the square root of 6. And now I can finally get rid of my addition. So my best answer is x equals negative 5 plus or minus the square root of 6. And that's it. Done. The keyword is stapler. The keyword is stapler. All right, last one. I'm going to go pretty quick. Like I said, it's all review, everything we've been doing. So once again, number 1, I have a radical on the bottom. The radical cannot be broken down. So the first thing I do is I use my conjugate box. Get your free point. It's an easy conjugate. So I just take whatever it looks like and rewrite it again. So I put radical 11. His soulmate is radical 11. I copy that to the top, so the top and bottom are the same. So my best answer here is going to be 6 times 11. And remember, 11 is not in jail, so it's 6 radical 11. And then the radicals cancel each other out using the shortcut. I use that shortcut right there. Number 2, I see a radical on the bottom. I make a conjugate box because I see a radical on the bottom. It's a hard conjugate. It looks like this, so its soulmate's going to have a plus sign in the middle. It's the only difference between the two. And then I put the same thing on top because remember, the same and same has to be on top. Now the top is going to distribute. 3 times 12 is 36. Radical 7 in jail, 3 not in jail, so it's 3 radical 7. The bottom, I'm going to use my conjugate shortcut. So I take 12, remember, I take 12, so I'm using this shortcut right here. A squared minus B. So I take 12 and I square it, I get 144. I just take 7, I subtract it, minus 7. So my best answer for this is 36 plus 3 radical 7 all over 137. That's it, done and over with. Now, if you want to split it, you could. You could put 36 over 137 plus 3 radical 7 over 137. I probably wouldn't, but you could. 3, pound is backwards, because that's what we've done every time I see one variable equal sign. There's no subtraction, no addition, no division. There's multiplication, I'm sorry. There's no multiplication. I don't know why I said that. Exponent, so I square root both sides. I end up with A equals plus or minus the square root of 300. 300 is not perfect, but 100 goes into it 3 times. So A equals plus or minus this 100 turns into 10. This 3 stays in jail forever. We are done. Number 4, pound is backwards. I see subtraction, that's why I add 5 to both sides. And with x squared all over 49 equals 3. Now I'm going to multiply because there is division, so I get rid of multiplication and multiply both sides by 49. I end up with 147, so I get x squared equals 147. Now I can square root both sides. I get x equals, remember plus or minus shows up when it's the most common mistakes, people forget the plus or minus. Now luckily guys, I know that 47 is perfect because I just multiplied by a perfect number, 49. So 49 gets to leave jail, so your best answer here is x equals plus or minus this 49 turns into 7. This 3 stays in jail forever, so that's your best answer. 5, exact same concept, PEMDAS backwards. So I see subtraction, so the first thing I do is I add 10 to both sides. I get 3x plus 5 squared equals 17. No subtraction's gone. The addition is actually in the parentheses, so I can't get rid of that addition yet. No division, multiplication. That's why I divide both sides by 3. And it's totally fine that this is an ugly number. I'm going to leave it as x plus 5. I'm going to leave it as 17 over 3. It's totally okay to leave. Don't discriminate against fractions. Fractions are our friends. So now I'm going to square root because I have to get rid of the exponent. And it's totally fine that it's there. I have x plus 5 equals plus or minus the square root of 17 over square root of 3. I just split my fraction now because I felt like it. I'm going to do it later when I go to simplify this radical anyhow. 9 minus 5 from both sides. So a great answer, not the best answer, but a really good answer is negative 5 plus or minus the square root of 17 all over the square root of 3. Now remember, I have a radical on the bottom just like we did before with conjugates. So I am just going to real quickly square root of 3 over square root of 3. That's the conjugate box to make the radical on the bottom go away. So the absolute best answer for this is negative 5 plus or minus the square 17 times 3. They're both in jail. So you could do 17 times 3 to get 51. So I have the square root of 51. Let's write that nicer. All over 3 because of the conjugate shortcut. That's the best answer. And that's it for number 5, and that's it for this long video.